water monitoring, tools and technique. Student, now we're going to use all the skills that we learned in the past and apply onto this session. Qualitative analysis and quantitative analysis. What's the difference? Qualitative analysis purpose is to identifying what type of ion in it. Quantitative analysis is to find out how much in it. Let's see. Qualitative analysis, you want to find out what sort of ion. You can do by flame test to confirm is it calcium or is it copper. We do the early precipitation test. Is it Ag, Pb, or calcium, or barium, so that you can identify the ion. Or negative ion, copper or sulfate, so you can identify. Qualitative analysis. Quantitative analysis is to find out how much in it. Once you identify how much in it, the component in gram or in concentration or in percentage, as in acid-base neutralizing, titration, to find out the unknown concentration using acid-base neutralize, or using precipitation rule to find out the unknown sulfate, how many grams of sulfate. Or after that you use AAS to find out how much in ppm, how much in ppm, which is mg per liter on your sample. Total dissolved solid. Total dissolved solid is to determine the salinity of water. Salinity, saltiness, NaCl. You can use as evaporation basin. So to slowly evaporate, do not bubble, because if you're bubbling, some NaCl also will evaporate. The residual always will be very little, so you measure not in gram, but rather using mg, milligram, 1,000 times smaller, to measure this total dissolved solid. As NaCl, they will make up about 99% of all the iron. So using this method, you can measure the major type of iron, NaCl. If the iron concentration too low, ppm, this mg per liter won't work. Then you might use some other method, like AAS will give you a more accurate calculation. One good method, using a conductivity meter. The theory behind is iron conduct electricity. More iron means more conduct electricity. What type of iron? As I say, 90% going to be NaCl. So more ions, more conducting electricity, also indicate more NaCl. Method. Example. When there is a mixing sand and salty water, you use a filter and collect the water. You have two components, the sand which undissolved, NaCl dissolved. You evaporate it dry, the residual plus the paper minus the paper give you the net residual, the undissolved. The bottom, you put it onto a basin, evaporate it dry. The basin plus the solid minus the basin. Now you give you the net solid value. That is the dissolved solid. Student, be careful. Those undissolved solid, which is the top one, the dissolved solid, which is the bottom one. Total dissolved solid is measuring this total dissolved solid, the bottom one. That is what we're measuring, the dissolved solid. After we test the main ion Na and Cl, now we're testing the other minor component, the positive ion first. We use precipitation rule to identify as if Ag, Pb, heavy metal, we use chloride to precipitate. Calcium indicate hard water. We use sulfate to precipitate. Once we identify the ion, then we quantify by AAS. As we say, now I'm using the lamp, shine the light through and get the reading. Here, put the calibration curve and you will find out how much concentration of calcium in ppm, mg per liter means. For example, how do we identify hardness of water? First, using a soap, see if they form leather with soap. If they form leather with soap, that means this one are low in calcium, not many calcium. We call soft water. Australian water is soft water. But if they do not leather, they form precipitation, sticky scum, stickiness. That means this may be a hard water, which high in calcium and magnesium. Next test, precipitation test at school. Calcium precipitate with sulfate. You will form precipitation. Further confirm, flame test. It will turn red with calcium ion. In the lab test, they're using EDTA to precipitate calcium, which give a more accurate calculation. And of course, positive ion, you can use AAS to quantify how much. Negative ion, chloride, sulfate, carbonate, very common that we test for water. As we learn, sulfate, we can use a soluble barium to precipitate. Chloride, a soluble Ag to precipitate. Carbonate, we can use acid to see if they form bubble. Of using again precipitation test. Testing carbonate, what does it indicate? Testing carbonate, it indicates calcium carbonate, hard water. You can use acid, see if they bubble. Sulfate. This is always we testing the fertilizer in concentration because plant needs sulfate. And that's one important component in fertilizer. We testing by precipitate with soluble barium. Phosphate. This is the ones causing eutrophication. You're using Ag soluble, a soluble Ag. Do not confuse sulfate with phosphate. Phosphate which cause eutrophication, not sulfate. We also test chloride. If high in chloride means what? Means high in sodium chloride, salinity. This also you can use Ag soluble to precipitate AgCl, which darkening in light. Dissolved oxygen. The oxygen that dissolves in water and is always very low. Oxygen has a very low solubility in water, only 9 ppm at 20 degrees. 9 ppm means 9 mg per liter, very low. But it is very important for all fish. Lower than 5 ppm, the fish die. We're using a calibrate oxygen sensor to sense the oxygen concentration. Old method called the Winkler method will no longer use. Level of dissolved oxygen is a good indicator to see the water quality. Always high in dissolved oxygen indicate good water. Low in dissolved oxygen, bad water. Simple as that. Because dissolved oxygen, they very sensitive to temperature or organic waste or those pollution. If low in dissolved oxygen, always indicate pollution. Example, heat pollution. Water getting too warm. Oxygen do not dissolve. The dissolved oxygen will be low. Organic waste, bacteria build up. Bacteria use oxygen. Also, oxygen, dissolved oxygen will be low. Eutrophication, you will have very, very low dissolved oxygen. BOD, biochemical oxygen demand. This is to measure all the organic pollution, bacteria, example E. coli. Because all bacteria, they will use up the oxygen when the time they break down the food. Now let's see. The testing of BOD is all the aerobic organism, those bacteria live on land. They will use oxygen when the time they break down the food. We're measuring this by 5 days at 25 degrees. Now let's start. Now I collect some water from a river as a sample, and I suspect would there be bacteria in it. And now I'm going to do the testing. The testing technique. First, I put in some food. Once I put some food, I put the lid on. The bacteria will wake up and start eating the food. All the aerobic bacteria, they will use oxygen to break down food. So I measure 5-day BOD calculation. On day 1, I count that is 10 ppm. But after days go by, in 5 days, bacteria will eat the food and use the oxygen. Come to day 5, I only have 3 ppm oxygen left. The difference is 7 ppm, very high ppm, means high bacteria. If I do on another sample, I get from a different river, I also suspect, do they have bacteria in it? I do the same trick. I put in some food with the lid on. I do a 5-day BOD calculation. Day 1, 10 ppm. After 5 days, still 10 ppm. The difference of BOD is very low, indicate they have very few bacteria. So in water sample, if BOD more than 4 ppm means pollution by bacteria. Low dissolved oxygen always indicate pollution, as bacteria use oxygen. One common example, eutrophication result from algal bloom. You will find the dissolved oxygen very low. BOD and dissolved oxygen, you will find one very interesting relationship. When BOD is high, dissolved oxygen always low. If BOD is low, dissolved oxygen always high. So they're in an opposite relationship. Turbidity is to measure all the big particles suspended solid in water that make the water murky, cloudy. These suspended solid usually are the clay, slate, plankton, or some industrial waste or sewage. We're using a sachet dish, as on the picture. You lower the dish into the water and cross the mark when the mark no longer seen. The greater the concentration of the suspended solid in water, the quicker that you will be disappear, and sooner you don't see the dish. So what's causing from turbidity? Commonly, soil erosion or eutrophication. They both will bring turbidity. Student, so far you've done all the testing now. And now let's revise. On the positive ion, if the water contains acid, it could be causing from acid rain, you can use the pH indicator. High in Na, how do you test Na? Na indicates salinity, NaCl. How do you test? Total dissolved solid test. Calcium indicate hard water. Testing by soap, see if they leather. You can use flame test, precipitation test, EDTA. Pb indicate heavy metal. Testing PbI2 precipitate yellow, bright yellow. All these positive ion tests can use AAS to identify how much would be the concentration. So after you do the precipitation test, now you can use AAS to find out the quantity, how much. Now we talk about the negative ion test. The negative ion chloride indicate salinity. Testing by two methods, AgCl precipitation. Another way, total dissolved solid. Carbonate indicate hard water. Testing by acid with bubbling gas. You put acid, gas will bubble. Sulfate usually we use for testing for the fertilizer. Barium sulfate precipitation. Nitrate indicate eutrophication, as in phosphate, also eutrophication. Remember, phosphate and nitrate cause eutrophication. And what will be the best test? In fact, the best test is using the BOD and dissolved oxygen test. And remember, when you come to BOD and dissolved oxygen, in eutrophication situation, the BOD always will be high, dissolved oxygen will always be low. High BOD, low dissolved oxygen. So this is the typical example. These two, BOD will always high, dissolved oxygen will be low. Test organic waste. Same as you testing eutrophication. Where's you test the organic waste common? City area. Again, it will be high in BOD, low in dissolved oxygen. Oxygen testing as a basic test to see if there is any pollution from heat, pressure, or bacteria. You're just using an oxygen meter. Turbidity test. Any soil erosion or eutrophication make the water murky. Technique using a HSC disk. Student, learn this summary well. Now, water monitoring. River source. How you're going to test dissolved oxygen? Oxygen meter. Mining. Heavy metal, for example, Pb, should be acidic. Use PbI2 precipitate yellow and use AAS to quantify. Query should be base. Make the water hard. How do you test? Precipitate calcium sulfate, flame test, turn red, or soap test, form leather, or EDTA to quantify. BOD. Turbidity test, high in BOD, low in dissolved oxygen. Log forest, HSC disk. Farm area, high in phosphate nitrate, algal bloom, eutrophication, Also, turbidity test, BOD will be high, dissolved oxygen will be low. Asterisk. NaCl, total dissolved solid, use evaporation disk. If in low concentration, you have to using the lab test using the conductivity meter. Student, learn this summary well and learn this testing well. This is the summary of all your monitoring.